So today we're starting spherical geometry. So the things that we will look at are arc lengths. So an arc length is just when you're finding a distance around the circle, like so the edge of the circle. We'll look at area of a sector. So that's when you're actually finding a section of like a piece of the circle, and you find the area. And then we'll look at area of a segment, which is actually when you're a segment is just a little bit. So we actually draw a little line across like that, and in there would be what we call a segment. Okay, so we're going to look at those things, and we have a formula for all of them. And the first one we'll look at is arc length, which is here. So they call an arc length, they're using the letter S used in the formula. Okay, so with the formula for arc length, you can see, so they're just using the letter S there, and you can see you've got pi, so that's just the button on your calculator. You've got radius, then you've got the angle. So that's the angle of the section of the circle they're talking about. And then you go divided by 180. So if we have a look at this one, they said the circle center is at O. It has a radius of 10. So we know we've got 10 centimeter radius. And the angle subtended or extended that they're talking about. So they're talking about A, B, C here. And they told you that it's 120. Now they're saying find the arc length ABC. So that means you just got to find this outside area there. Okay, so if we go and write the formula, so the formula for arc length is pi times r over the angle over 180. So in this case, it would be pi. The radius is 10 times the angle, which is 120 over 180, and you'd get your answer. So it said to do 1 decimal place, so I got that to be 20.9, and it'd be centimeters because it's a length. Okay, so we've actually just found the length of that outer edge of that circle in the section they want us. Okay, so the letter S is just used. That's what they call arc length. I don't know why, but they use the letter S for it. All right, let's go on to the next one. So if we're asked to find an area of a sector, that's when you can see in the diagram, we're getting this section of the circle. So really, you can see the formula, if you look here, for area of a circle, the formula for area of a circle is pi r squared. So you can see that's in there. All you're doing is saying how much of a full circle you've got. So if we look here and we were doing this example, there I'm going to say the area of the sector. Okay, so you've got your formula there is pi r squared over the angle over 360. So pi, now the radius here is 10 times 10 squared, times 120 over 360. Okay, and then we just do that. So you can see when it says we're actually finding the area of the minor sector. Why is it called the minor sector? Because if you look at that circle, that would be the smaller piece, wouldn't it? Yeah? And if we were finding the major sector, that would be the big piece of pi. Okay? So if we went to go find the major sector, if this is 120, but it's got to be a full circle, doesn't that make that how many degrees? It'd be 360 minus the 120 equals 240. Yes? So the major sector would equal, still again, pi r squared over the angle times 360. But in this case, it'll be pi times 10 squared, but times 240, because that is how many degrees in the major sector. I'll just get the answers. Units would area be? Centimeters squared. Good. So that's what I'm looking at when I do it, and they also making sure 2 decimal places. So that other one is 209.44. All right, so let's have a look at this exam question. Now, it's question 8 in your trig unit, so question 8 in your trig unit, that means it's fairly far into it. You've only got 9 questions in the unit, so it was meant to be a tricky one. And it was more that you can't see it, and then as soon as you know how to do it, very easy to work out. So you've got 3 circles of radius 50 millimeters are placed so that they just touch each other. The region enclosed by the circles is shaded in the diagram below. The area of the shaded region in millimeters is closest to. So what you have to realise is that if you go, so here are the centre of the circles. If I go to the edge, that's the radius, isn't it? Yeah? So that would be 50 millimeters. If I go from there to there, that's also 50 millimeters. And then notice if I go from that centre to there, it would be 50, and then back out there to 50. So can you see that I actually create a triangle in there? Now, I'm actually creating a triangle that looks like this. Isn't 50 plus 50 100? So are the sides all 100? So does that not make that an equilateral triangle? Yeah? So equilateral triangles mean that's 60 degrees there. Okay? So what I can see now, if I look in here, I know that that is 60 degrees in there. So can you see I actually create a little sector of the circle, don't I? Yeah? Where I've got 60 degrees. Can you see that would be like the area? Now, could you see, so really what I have is 3 sectors in there, don't I? Can you see that? Like that? So wouldn't this shaded bit in here, I'll make it a bit darker for you. This shaded bit, if I found the area of the triangle, like the full solid, and then I minused the 3 sectors, would that not give me that little black bit in the middle? Do you see that? Yeah? So off we go. What we're going to do is we're going to find the area of a triangle. Now we've got, it depends what you want to do, which formula you want to use, but we can use Heron's formula there. So remember where area equals. So for Heron's, the area equals S. Remember S minus A, S minus B, S minus C, where this is A, B, C. Okay, and then the area, we're going to minus 3 areas of a sector, which we know the formula is pi r squared over angle over 360. And then that's going to give us the answer. So let's go do that. Okay, so when I plug all that in, I get 403. So our answer is there. So the reason why this is question 8, so it was hard to see that. And what had happened was, and I'm just going to quickly show you, what had happened in the previous year before, or the kids had seen one where it had 4 circles like that. And so they were sort of all ready for that one, and then they could not see the equilateral triangle because the year or the one before, I can't remember. See here, you could get a square in there if you're told the radius. Can you see that? Yeah? So they knew the square one, but they didn't think of a triangle for the 3 one, okay? So that's what we've just got to think about. Maybe be open to what shape could we get inside there. With this one, so if you had a square, can you see you've got 4 sections of the circle. Say you're trying to find this bit in here, yeah? Say that was a question. You've actually got 4 circles, yeah? So what we could say would be the area of the square, yeah, minus 4 of these, yeah, would equal that black area, yeah? Is that right? Do you see like that? That bit in there. Okay? So it's the same concept where you have to realize that the radius is, there's two radiuses there, isn't it? So you can work out this is a square because they're all exactly 2 radius wide. Okay, so area of a segment, as I said, the segment is when it's this bit, they've coloured it in there, just that bit in here. So it's when you've sort of got the section of the pie and then just that top bit like that, okay? So there's a formula for it and it's here, and you can see here, and you need the angle. So there, you need to know this angle of the section they're talking about. You need also the radius, and that's all you need, and then you follow this formula. So down here we've got an example. If I had to find, they've told me the radius here is 10, and they've also told me that that's 45 degrees. So they've written out the formula here, and all they've done is every time they saw R, they put a 10, and when they've seen the angle, they've put 45. And you find the area of that segment. So just be really careful. It's pretty easy because they'll probably give you a visual of what you're finding. So you just find the visual of your formula sheet. So here over in question 5, I've found the exam question they had. So question 5 is not too far, like it's not too difficult. So they said, which of the following calculations will give you the area of the shaded segment? So you can see that it's the segment. So I'd write the formula for that, which is, I'm going to say it's pi times r squared over that, over 360 minus a half radius squared sine the angle. So up here, I'm going to plug in. So the radius they're telling me is 112. The angle is 75 over 360 minus a half times 112 squared times sine 75. Okay, so we're looking for that written out in our thing. So we've got pi, sorry, this should be squared. So we're looking for pi times 112 squared over 75 over 360. This looks good so far. Minus, this looks like it. Is that it? That's what I just wrote out. So there's the answer. Okay, so sometimes I'm trying to put this one in too. Sometimes they don't get you to work it out. You just had to find the formula and substitute in. Okay, because there's programs, I'm sure, written on your calculator where you can just it'll spit everything out. So they're trying to get that you can get the formula out. Exam question, but it looks like question 1, so it's fairly, I don't think it was question 1 to be honest, but it was a thing. So question 7, is it? Sorry. Okay, so with this one, it says find the area of the shaded region of the wiper. So remember, when you're on the car and the wiper and it only sort of does that arc rainbow section part. So what I'd found for you guys, and that I've attached this in your notes, is this formula sheet where it has a formula for it for you. So here's the area of how to find when you've got this section like that. So I just flick ahead to show you anything like that. So let's go have a look. What it means here, you've got 2 radiuses. So they call the big radius is the big R, and the little radius is got the little r. So over here, if you have a look, from here to here is the little radius. So little r is 9. Now from here out to here is the big radius. So be careful, what would that one be? It'd be 30 plus the 9, which is 39. So if we go and use this formula over here, I'd go area equals, I'm going to go pi, and I'm going to do big radius, 39 squared minus the little radius, and then I'm going to times it by, now this alpha, that just means the angle that they've given in here. So they've told me that, which is 110 over 360. Type that in your calculator, exactly what you see there. Okay, so I got it to be 1,300 382, which is B. Done. So there would have been long-winded ways to get that, like find the bit section of the small one and all that, but I've got that formula there. Let's just use that. Yeah, we get that shape, bang, let's go. Save you a whole lot of time. This is the formula sheet I've attached in your notes. It's near the back, I'm pretty sure. You've got them, so in case you've got... Okay, so there's the formula sheet that I mentioned, and that's 19A.